Now we're going to be moving on to actual application examples using AIM-TEX block diagrams. So as mentioned before, pneumatic plug doors are a very popular application. They've been the most popular type of door in the public transit industry. However, they are slowly being replaced with electrical drive plug doors. These doors feature accurate obstacle detection, easy installation, and require less maintenance as checking for leaks in the pipes is not required. The below example shows a simplified block diagram of an electrical drive plug door system, where the voltage is 110 VDC. The power goes through an EMC filter first to filter out unwanted noise. Two AM10 EWs convert the 110 VDC to 5 volts to power the controller and the motor. Having two separate converters for the controller and the motor helps isolate the interference coming from the motor. Next, we're going to be moving on to screen doors. Screen doors have been widely installed in major stations around the world. It prevents the passengers from falling off the platform and helps HVAC systems run more efficiently. The below system uses a pneumatic solution to control the door opening and closing. The system voltage is again 110 volts and features an UPS power supply in case of emergency. The input power goes through the first filter, which feeds directly into the motor. The second filter filters out the noise coming from the motor and sends 110 volts to the motor driver. The AM20 EW converts the 110 to 15 volts and serves as the main power supply of the control circuit. The AMSRI, a high-efficiency switching regulator, steps down the 15 volts to 5 and powers the MCU. The isolated CAN transceivers are powered by the AM10 CW to ensure the signal quality. Finally, an AM1LS converter serves as additional protection and powers the hall circuit, which can be used to detect obstacles at the gate. Now moving on to train information displays. The information displays tell the passenger their current location and the upcoming station. The display receives the data from the train information system and displays it accordingly. As the signal line has to go through several cabins, it tends to pick up a lot of noise. The display unit must be designed so that it is immune to the noise and interference generated in all the railway environment. To ensure the information is displayed correctly, the below example uses an AMFW110 EMC filter to filter out the noise picked up by the power line. The AM75QB serves as the main power supply for the entire display unit. It converts the 110 volts to 24 and powers the LED matrix directly. An AMSRI switching regulator converts the 24 to 5 volts and powers the MCU, display driver, and 485 communication module. Finally, an AM1DR isolated converter is used to provide the power to the 485 signal line. The isolated communication module helps further reduce the chances of the display unit being interfered with. Now we're going to be talking about the bogie monitoring system. The bogie monitoring system monitors the bogie's status, including the steering angle, vibration, and temperature. The system can identify if there are any abnormal or possible failures on the bogie based on the data pattern that is sent out. As the traction motor is located within the bogie, the sensors are subject to extreme electromagnetic interference. Similar to the display unit, the monitoring system also uses an AMFW110 to ensure its electromagnetic immunity. An AM50QB, following the EMC filter, converts the 110 volt system voltage down to 15 volts and powers the bogie sensors. To add an extra layer of reliability, a second isolated converter, the AM15C, is used to power the MCU, HMI, and communication module. Now we're going to be looking at train VIP seats. These VIP seats are seats found in high-end cabins. Each seat requires an independent control system to control its position. The below seat control diagram uses a similar power solution as the bogie monitoring system. An AMFW110 is placed at the input of the system to provide the necessary EMC protection. An AM100QB is used as the main converter to convert the 110 volts down to 24 and powers the seat motors directly. Unlike the bogie monitoring system, the seat motor control wires do not span long distances and are not exposed to the same electromagnetic interference. Hence, the power of the control circuit is provided by the AMSRI switching regulator, which converts the 24 to 5 volts. This AMSRI is a non-isolated DC-DC converter. And finally, we're going to be looking at an operation monitoring system. The train operating system is the heart of the train. The below example shows a simplified block diagram of this system. The system implements an EMC protection device with an input overvoltage protection feature at the input. As the monitoring system needs to communicate with multiple devices on the train or the trackside, multiple isolated converters are used to avoid cross-interference between each input-output module. Thanks for tuning in, guys. Hope you learned something today. Again, Aimtec has a very large product offering of railway power converters that go anywhere from low power all the way up to 250 watts. If you have any customers that require power conversion for railway, be sure to check out Aimtec. Have a great day, and we'll see you in the next one.